All right, we're going to get going here. So my name is Trevor Trinkino. I am a quantitative trader and researcher down in Austin, Texas, with a firm called Kirshner Trading Group. We have offices down in Austin here. We've got some offices up in New York and Chicago as well. We've been around for a little over 20 years. We've had guys, most of our guys for many years have traded more on the discretionary side and have been pretty successful over the years doing it. We've got guys trading remotely with our technology all over the world. And recently, in the last few years, we've really started to push on the automated algorithmic trading side of things. And particularly recently have started to do a lot more research into machine learning, AI, and how to leverage that to try and find some alpha in the markets. Within Kirshner, we have a subsidiary called CloudQuant, which is more or less a backtesting engine. Bring up the page here. It basically allows anyone, no matter where they are in the world, to log on to our website here, which is just www.cloudquant.com, and access all of the same resources that we use every day to create algorithms here. We've got high frequency tick data back to the beginning of 2011 for every US equity. We have a bunch of level 1 and book data. We are incorporating new alternative data sets as often as we can, sentiment stuff, Bloomberg fundamentals, things, anything along those lines. The whole idea is that anyone can come on here, code up a strategy using Python and using our environment, and then backtest it and see how it would have done back to the beginning of 2011. And then get that data and work with it outside of CloudQuant and the Jupyter Notebook. Do the research, come back, iterate over the algorithm, and improve it. I use CloudQuant every day. Similar product to what you guys could use if you were to go onto the website here and log in. And I use it slightly different to how a lot of the users do, just because I focus mainly on machine learning and applying artificial intelligence. So today I'm just going to go through my kind of workflow A to Z, simplify it a little bit, and just show you guys kind of how we approach the problem and the steps we take to properly develop the algorithm, utilizing CloudQuant, utilizing machine learning. And hopefully we make some money with it. So that is that. We have, just for you guys on the webinar here, we have a questions box. We also have a chat box. So if you guys have questions for me throughout the webinar, make sure to throw them in there. If I see them, I'll try and address them immediately. Otherwise, I will make sure to talk about them at the end of the webinar, and we will do a kind of question and answer piece as well. But feel free to throw them in there so I can address them as they come in. All right, so here's a little disclaimer we need to show you guys. Basically just saying, telling you about the risk, and while this is a powerful strategy, there's obviously no guarantee in the markets, as I'm sure you all well know. All right. So today I'm going to focus on a single type of machine learning algorithm, which is within a group of machine learning algorithms called ensemble methods. And we're going to look at an algorithm called random forest, which is probably one of the easiest ones to start with right out of the box, but it's also extremely powerful and definitely I think where you guys want to start if you've never done this before. It's pretty robust to overfitting data, which is a really big problem, obviously, with building algorithms, and like I said, pretty easy to use. So just kind of high-level overview of what machine learning is, and at least how I kind of interpret it. I think of it as it's definitely not as complex as a lot of people make it out to be, in my mind. It's more or less just a structure of math equations or an algorithm that allows a computer to search through a lot of data very efficiently. And then, the computer can either create a group or groups of nested if statements, or it's going to create weights that it assigns to variables and combinations of variables, and it's going to update these weights through an iterative process. Once it kind of creates these weights, or it creates these nested if statements, and there's all sorts of different ways that different machine learning algorithms do this. We'll kind of go over quickly how the decision trees and the random forest do this in a second. But once it creates these weights, it saves them as a rule set that it can later apply to new data it hasn't seen before and make a prediction based on this set of rules. And then specifically, we're going to be talking about, like I said, random forest. Random forest is just a group of decision trees. It's called an ensemble method. It basically takes anywhere from 10 to thousands of decision trees and builds them on different subsets of the data and subsets of your variables, and then creates different nested if statements for each one of these 10 to 1,000 decision trees. And then at the end, we'll kind of combine all these together to hopefully get a nice generalized answer and predictor for you that is not overfitting the data to one specific, one specific piece of it. And then generally there are, I would say one of the biggest difficulties about machine learning for algorithmic trading is just that market conditions change so quickly. So you can't, you need to train your machine learning algorithm on data that is similar to what you're going to be predicting on. You can't, for certain strategies, you can't look back too far in time since the market conditions have changed. But you also need probably, definitely over 10 to 20,000 at the bare minimum samples or trades for the machine learning algorithm to look at, but you really want to get over 100,000 to 200,000 in my experience. So while this is really powerful, it's probably not very well suited for traders who have really specific setups that only happen maybe once or twice a day in the entire market, just because there's not quite enough data there. So this is a lot better when you have more data, and something to kind of keep in mind when you're thinking about framing your problem and potentially applying machine learning. So this is just a sample decision tree here. Like I said, random forest is just a big group of these that are trained on different subsets of the data. Basically, what the algorithm is going to be doing is, it's going to take, say you have 100,000 trades and you have collected data on each of these trades. Maybe you've got 50 different variables that are applied to each of these trades, and I'll kind of go over this and how to do this in CloudQuant with Python in a little bit here. But say you've got 100,000 trades, 50 variables for each one of these trades that you collect at the time of potentially entering the trade. What a decision tree is going to do is it's going to look through each one of these 50 variables and look at every possible threshold that would split the data for each one of these variables. And it's going to split your data in a way that gives it the most information gain. You know, if we think about it in layman's terms, you could say a decision tree that you go through every day when you wake up is, you know, is it a weekday? Is it a weekend? If it's a weekend, you're probably not waking up quite as early. You know, so if it's a weekend and it is sunny outside, maybe you're going to go to the park or something like that. Just a bunch of nested if statements. Let me see if I can zoom in here for some of the people. So anyway, so this is one of my variables in this decision tree. Let's see if we can get this zoomed in a little bit more. So basically, it doesn't really matter what this variable is right now for you guys, but so say we've got all of our 100,000 trades here, and then this variable is called V to ATR to open. It's basically measuring the daily move as a percent of the average trading range from the open. You know, if that is less than 0.0773, then all the trades that satisfy that condition are going to go this way. All the trades that don't satisfy that condition are going to go this way. And then from there, you know, we're down at this next node here. This is the minimum RVol, so the relative volume that the symbol is seeing at that moment. If it's less than 9%, then we're going to go this way. If it's greater than 9%, we're going to go this way. And that's going to continue for each one of these different variables all the way until the end here, until at the very end, we now have a group of trades, and we can decide whether this nested if statement combination right here ends in more good trades as opposed to bad trades. So another thing to keep in mind that I didn't mention earlier, we are working with a subset of machine learning called supervised learning, which is basically where we assign a label to each trade. So every trade that happens that we're looking at in our previous data, we basically say whether or not it is a good trade. You know, you can say that in any way, shape, or form. It can be, we want the return to be positive for that trade. So any return, any trade that we've taken out of the 100,000 where the return is positive, we're going to assign a one to that trade. And any trade that has a negative return, we're going to assign a 0 to that trade. So now the machine can, so we've got about 50-50, 50,000 trades are good trades, 50,000 trades are bad trades. And the machine can then go through and find the patterns in not only the good trades, but also the bad trades. So it can, so it can try and steer us in the correct direction down the road. So once again, here's a decision tree. Really simple concept. It might look a little bit complicated, but at the end of the day, it's just splitting on the most useful variable at every different node here to create the most information gain. And what I mean by that is, it's trying to split the good and the bad trades as best it can. And then, random forest is just a group of these that is all built on a small subset of your data. So one of these decision trees might only get built on 20,000 trades out of the 100,000 and 20 variables out of the 50. So it's going to be slightly different than the decision tree that's built on a different 20,000 trades and a different 20 variables. In that way, the random forest is able to make more robust predictions and overfit the data less, like I mentioned earlier. So here's a general process and steps. First thing to do, you really have to frame your problem and then decide on the goal of the model. The more I get into this, the more I realize that this is probably probably one of the most important steps that is overlooked quite a bit. The machine is going to find basically whatever patterns you want it to find in the data. So you have to make sure that you're telling it to find the right patterns. You know, if we had labeled our trades hypothetically that and said that any trade that returned positive was a 1 and any trade that was negative was a 0, you know, there could be some complications with that, just because a trade that returns 0.0001 is labeled the exact same as a trade that returns 5% in a single day. So it's going to treat the patterns that it finds in that, you know, in those trades that barely return greater than positive, same as the patterns that it finds in the trades that, you know, dramatically rip up and make us a lot of money. And similarly, you know, if a trade loses a substantial amount of money, you know, maybe it loses 20%, there's a buyout, something like that, it's going to treat the patterns it finds in there as the same as if, you know, a trade that loses 0.001%. You know, so there's things to kind of keep in mind there. A lot of the labeling that I do is relative to the daily move. If we're doing a reversal, which is a lot of the trades that in algorithms that we build here, you know, what the reversal size is, or how much the trade rebounds from the bottom of the reversal, or the risk to reward that we see within a setup. After you kind of frame your problem, you need to decide a scoring or ranking system. This again sounds pretty simple, but can be fairly difficult. There is a trade-off in machine learning known as the bias variance trade-off, and for trading, it more or less means, you know, at least for us, we struggle with the trade-off between, do we want to take a lot of trades, or do we want our trades to be very profitable? Because we can train the machine to only look for the best of the best trades, and there's probably a good chance it will only find, you know, it'll find 70 or 80% winning trades, but it may only trade once a week in that case. And that is not really what we're looking to do. We're trying to get, you know, as many trades as we can, but also make those trades positive. So there is a bit of a trade-off there, whether you're looking for more trades that are decent, less trades that are great. You know, if you can set up a ranking system using a metric like log loss that would penalize trades that are further off, or if the machine gives a higher confidence to a single trade and it is not correct, you know, we can penalize the machine more for that. So there's all sorts of things to do there. Next step, and this is probably the most important step, definitely where I spend most of my time, is gathering and exploring the data, and then, you know, kind of curating that data to paint a picture for the machine that the machine can, you know, the machine can use to find patterns. Obviously, if you're creating an intraday trading strategy and you create a bunch of data points about the return over the past 365 days, it might be useful, but more likely the machine is going to find that it's more useful to look at the returns since the open, or the returns since the previous close, you know, maybe the previous week. So there are ways that I'll go over quickly at the end of this, ways to figure out what variables the machine really likes. But that is definitely where most of my research is spent, is just kind of in this finding data, and then curating that data to find the best splits in our decision tree back here that allows the machine to split the data in a way that it gains the most information out of each split. From there, we need to, most machine learning algorithms need you to normalize and center the data. For decision trees and random forests, you actually don't need to do that, but definitely a good habit to get into. There are other pre-processing steps that you need to do. You need to take out null values for a lot of machine learning algorithms. You need to handle infinity and negative infinity values, and in general, just kind of get an understanding of what your data is and what you're working with. From there, you need to split your data into test and training sets. So you can obviously train on a certain time frame and then test it on a different time frame. See how you did. Try a couple different machine learning models to utilize. They have their pros and their cons, and then you tune these things called hyperparameters, which we will go over in a second here, which are basically just kind of the knobs of the algorithm, or how the algorithm is structured. And then it's a very iterative process over and over again. So going kind of into code a little bit here, like I said, everything that we do on CloudQuant is in Python. Pretty easy language to pick up. I would say that someone could learn online in a few weeks, and within a few months be competent enough to start doing machine learning pretty easily. So we have all US equity data here. We are looking at trying to get some, maybe get some cryptocurrency data in the next year or so. Some futures data as well, I know we're interested in getting. But right now, we just have US equity data. More or less what I've done in this model, this might look kind of complicated here, but I've taken a very simple universe that trades over 50,000 shares on average a day, is above $2, and has a minimum of $10 million traded each day. So we're just looking at a fairly liquid universe, and then from there, I just did a really simple entry logic that says 120 minutes after the open, so 2 hours after the open. If the last price was less than the open, then we're going to buy, and if it's greater than the open, then we're going to sell. Obviously not the greatest alpha strategy or idea by any means, but it's something that I've kind of created here, and I'm sure we will have a post. We'll be posting this video online with FXCM on CloudQuant here. We'll also make a post, and I will share the Jupyter notebook that I'm going to go through, so you guys can kind of go play around with it, as well as the data that I collected from this algorithm. So you can kind of go through the steps yourself and see how it works for you. Anyway, with CloudQuant, we allow you to collect data on every entry. It's just in a Python dictionary. So down here, I have a couple functions that I call right before I enter the trade, and I just collect all these different variables that I have created or have found to be useful for this particular entry. I've got around, I think I've got around 100 here. Probably don't want to use that many. It definitely, you have a greater chance of overfitting your data the more variables you use. But anyway, we collect a dictionary of variables, and then on every entry, it's going to collect all of those variables at that exact moment based on our tick data. From there, we can run a back test up here with this new test tab. We're running from 2014 to yesterday. And then in our results tab over here, we get if I can find it real quick, we get a back test that would show us how we did. This one I was doing 1 share per, so I think we probably bought Berkay or something right here that threw it off. But anyway, we did not do very well on this back test, other than that one trade. But more or less what we're trying to do here is trying to get this data. So a couple questions that have come up quickly. We are going to be using live scikit-learn, which I will go into in a second here. As far as learning the code for Python, I would say just Google it. There's a site called learnpython.org that does really simple tutorials for free. There's another site called DataCamp that does some more kind of data analysis work. There's all sorts of stuff. Just Google it. There's a bunch of free stuff out there. Udemy has a bunch of classes. Udacity, Coursera, all those. Anyway, so we're going to download our trades as a zip file, which is basically just going to, it's either a zip or a CSV, depending on the size, and it's just going to collect our entire, our entire dictionary for each trade, every variable that we threw into that dictionary at the time of each trade. From there, I have pulled this into a Jupyter Notebook. Jupyter Notebook is just a really nice way to kind of break your code up into chunks and run different pieces of it at one time. And it just allows you to visualize your data a lot easier. For those of you who don't have this, if you just Google download Jupyter Notebook or download Anaconda, this will be guaranteed the first thing that pops up. So we're going to be using scikit-learn today for most of this stuff, and then as well as pandas and numpy, which are pretty standard kind of Python packages. Most of my research is done with a similar package called LightGBM or XGBoost, for those of you who are familiar with it, but basically this is slightly more advanced random forest in some sense. So anyway, here is our trade to CSV file, which we have just read in from our, after we downloaded it from CloudQuant. We get a little preview here. So basically we have our symbol, we have it's our exit time, but there's an entry time in here as well. And then we have all of these variables and what their value was at that potential entry. And each row basically represents a different entry point. All right, so as we move down here, first thing, definitely most important, just kind of visualize your data, understand what you're working with. A lot of times we gather data and we look at it from a high level, but we don't really know what's going on, and that can throw things off pretty dramatically for a machine learning algorithm if there are, if we're gathering data incorrectly or we're not normalizing our data. Obviously the absolute change in price on a stock like Google is going to be very different from the absolute change in price on a stock like Bank of America, that are trading at vastly different price ranges. So a lot of times we will normalize that price change with ATR or make it a percent change, something like that. Definitely something you got to play around with. There's pros and cons to everything, but you want your data to be normalized. So we've got our preview here. We kind of visualize this. We can look at our columns. What we're going to do is define which one of these variables we actually want the machine to learn off of. So what I'm doing down here with this little function is basically just saying from this D1 range variable all the way over to the entry collect.atr, which you can see if I do df columns. You can see these are some more of our variables here. This entry collect.atr right here, see the ATR is kind of the last variable that I want the machine to learn off of. So we've got our list of features here. This is probably, in general, way more than I would normally use. Normally I'm using around 25 to 50 or 60 features. If you have more data, you can use more, but if you have less data, you're going to overfit your data set if you're using too many features. So, this is something that you gotta, another thing you kind of have to play around with. Machine learning is not a cut and dry, you just do this step after this step and get your results. You definitely have to kind of iterate and play with each step as you go through it to get the best results and test things. So here are a few different checks that I've included in this notebook, and once again, I will send this out to everyone, or we'll post it on CloudQuant.com so you guys can come over and check it out and download it yourself. So we're checking that each feature is a float, just to make sure, integer features are fine if they are used for the right variables. Like this low last time, PM diff is just a second counter from the low point of the day to the last, or since we entered. So that being an integer is fine. But if we're, if our variable is supposed to be in a range from maybe -2 to 3, and it's an integer, so everything is rounding to whole numbers, we probably don't want that. We want everything to be a float. So, it'd be a decimal point. So that's something to check. Here we're checking for the percent of the column that is null. Obviously, if we have something like this 99.7% of this column is null, probably isn't going to be too useful. There's probably something going wrong there. We collected it incorrectly. In this case, it's just checking a really, really wide range that most stocks don't see. So most stocks don't have a value for this, but something to look at. Here, we're checking if any column is 0. Here, we're just kind of checking the range of each feature, so we can go through and look, make sure things aren't wildly off. Once again, decision trees don't need your data to be centered or normalized. Other machine learning algorithms like a neural net definitely do, but something to just kind of look at. And then right here, we're just looking at the number of, or percent of unique values in each feature. Okay, so from there, for this example, I have labeled my label for this is going to be our exit price minus the entry price over the ATR. So basically just the percent of ATR that we've gained in this trade. And the goal is to have greater than a 5% gain in ATR over the lifetime of the trade. So pretty standard. You definitely, some might see this and say, why wouldn't we want at least half of the ATR, a larger move in the trade? And that is, once again, another thing that you can play around with. That would kind of be a hyperparameter of your model in some way. Machine learning algorithms in general do better when the classes are balanced. So, if we have 60% good trades and 40% bad trades, or vice versa, we have 40% good trades and 60% bad trades that we labeled, that's probably going to do better than if we have 90% bad trades and 10% good trades, if that makes sense. So we are going to, this is our label right here. We've just added a column to the data frame that is return, and then if that return is greater than 0.05, we're going to assign it a 1, and if it's less than 0.05, we're going to assign it a 0. And that line right there is our label that we're going to feed into our random forest classifier. Right here, so you can say percent of target trades. We've got 43% of our trades are going to be labeled as good. So that's a pretty decent balance. Shouldn't run into too many issues there, at least with the random forest. This is just a little way to kind of visualize the distribution of the return. Next step, we need to split our data into training and testing sets. So obviously we're going to, we're going to train our algorithm on a certain time period, and then, test it on a walk forward basis on the future, future time. We obviously cannot train it on, if we're looking to judge how the machine learning prediction does, we can't train it on data all the way through the present and then test it on that same data, because it's going to be testing on patterns that it's already seen. So that makes sense. A lot of people will split this into 3 sets as well, where they have their training set, they train the data on, the machine looks for patterns in, and they have their testing set, which is where they kind of tune their machine learning algorithm. And then they've got a 3rd set called a validation set, where they will hold off until the very end to check how they do. Because in this testing set, you're going to overfit the structure of your machine algorithm to this, if that makes sense. So from there, we break our data frame up into the part that we want it to learn from, which is our features. So you can, if you remember back up here, we defined our features as this list of variables that we collected. So this is just going to be the, all of our features for each trade, and then our Y train, which is just the 0 or 1 label that we assigned to each trade right here. And then we're going to do the same for the test set. We look at the lengths. We're over 200,000 for our training set, so we should be good to go there. Down here, we're using scikit-learn's imputer function, which is really nice, easy function that basically just replaces all the null values within your data frame and replaces them with the median of that column. The reason I'm using median is just because market data is pretty noisy. If we were to use mean or something like that, there's a good chance the mean is going to get thrown wildly off. What we're trying to do here is basically tell the decision tree in some sense to ignore that value if it's null. We can't explicitly do that because back over here, when we come to one of these splits, if we have a null value, the decision tree is not going to know what to do with it. There are some more powerful algorithms like XGBoost and LightGBM that I mentioned earlier that can handle null values. But as far as scikit-learn's random forest, we need to deal with this ourselves. So anyway, we create this transform class, and then we fit that to our training data and then transform it. So this is basically just applying this function to our training data. And then we save all of those median column names, and we then apply that same rule set to our test set. So we can then, we can make predictions with the same rule set on the test. So here we go. This is our random forest classifier. Scikit-learn makes it really, really easy to just kind of plug and play this stuff. I've set the hyperparameters. These are all of our hyperparameters here, which basically just tell, give the specifics on the machine learning algorithm. I've set them to just some kind of simple default values. Max depth is going to relate to how many splits you can do. So this one is going to have a max depth of 1, 2, 3, 4. This tree, just kind of the number of levels that you can go down. The more you go down, the more complex and powerful your machine learning algorithm is going to be, but also the more likely you're going to overfit your data. So something that you need to be aware of. Number of estimators is just the number of trees. So we're going to build 100 decision trees on 100 different subsets of the data, and then average all those out to get our final predictions. So this clf.fit basically just goes through and finds that patterns. I think this took my computer maybe 30 seconds to run, so not too bad. As you add more estimators or allow a deeper max depth, it's going to take a lot longer. And some more, if you get into neural network stuff and you don't have a GPU, or you get into more data, sometimes these things can take days to train. So anyway, this is we're calling our prediction function on the X test data set. So basically it's looking at right here, it has found all the patterns. It has saved all those patterns in this little CLF object, saved all those nested if statements. And now it's applying all those nested if statements to the test set or the out of sample data. We get those predictions. This is just kind of a, here's our label. And then you can see what the classifier is predicting. So we've got all zeros here. Obviously not very great. All right, so down here, these are just some measurement scores that scikit-learn gives you out of the box that makes things pretty easy. A lot of people use accuracy, something to be aware of with accuracy. If our target class is 43% of the data, that means that 57% of the data is bad trades and 43 is good trades. If we are trying to optimize accuracy, the classifier could hypothetically guess no on everything, and which means it hasn't learned anything at all. It just gets no on every single trade, and it would get an accuracy of 57%. So that's why I don't really use accuracy too well. It works well if you've got a perfect 50-50 split, but beyond that, can be very misleading. So our scores here, not very great. Obviously, we've just kind of done this without any research. Our alpha signal isn't very strong. But basically, this recall score, you can think of it in terms of baseball or something like that, as for every strike that comes over the plate, how many times do you swing? For trading, it'd be for any good trade that the machine looks at and tries to predict, how many does it correctly predict as a 1? And then precision score is out of all the trades that it predicted as a 1, how many of those were correct? So this is kind of an accuracy score of only the trades that said were 1. Down here we get our return details. Our original return out of the 229,000 trades was minus 1.7. With this kind of out of the box, we've actually gotten worse. So we're down to minus 0.05, and we're only taking 5,000 trades. So something to be aware of. This is pretty powerful, but if you're just, straight out of the box doing some random hyperparameters on an alpha signal that isn't very strong, like the one we have here, it may not, and doing, the number of features we have is probably way too many. These features haven't been curated very well. If we've got these massively large null columns, that's probably not very helpful. Anyway, so this is, here are our scores, not super great. The next thing that we kind of do would be to adjust our hyperparameters. This grid search CV basically does a cross validation, which means that it takes a subset of the data, trains on it, and then tests on the subset that it left off, and basically finds whatever hyperparameters are going to perform the best out of sample through that process. And this grid search CV takes a while to run, but it will try every combination of n estimators, max depth, min samples per leaf, and job is just telling it to run on as many cores as my machine has. Doesn't have anything to do with the actual machine learning algorithm. So once we get that, this is going to spit out what our optimal parameters are. And then we can go through here and retrain with these optimal parameters and see our improvements. Our precision has increased by 4%. We go down here to our new classifier returns, and our median is now positive. We're still negative on average slightly, but we have improved basically straight out of the box without doing any work other than just kind of running things on scikit-learn. Going back over here, this was our initial scorecard from CloudQuant, the very first the very first algorithm where we just collected data. So this was our initial alpha signal without any machine learning. Obviously pretty awful here. This next iteration was not the random forest round that I showed you here, but this is actually an algorithm that I have created. One of the first iterations of an algorithm that I created that is using random forest. It says it's using XGBoost here, but it's actually using random forest. But I have optimized these, I've done some research and optimized these hyperparameters. And then probably the biggest thing that I really did here to get this backtest and this scorecard is I looked through all of the features and looked at which ones were most important, which we can do at the very bottom here. We can sort by our most important features. Once again, this, our classifier object has a feature importance attribute, which is really nice. So I look at what's high up here, and then I try and create other features that are similar to that. I'd cut out probably all of these down here below some threshold, throw in some more, try and find data that the machine can split on. And that's, like I said earlier, that's definitely where most of my research is focused, is finding this data. Yeah, and then from there, this was kind of the final iteration of an algorithm that we have trading in live, back tested. We've got a Sharpe ratio of 3.2, net edge of 20 cents per share. So it does pretty well. And this, once again, was just after more iterations of creating better data, tuning our hyperparameters more. And then I believe this one actually used that light GBM model, which is a little bit more powerful. Yeah, so that's basically the end-to-end kind of step-by-step process. Collecting data in CloudQuant here, pulling it into our Jupyter notebook, and then going through this whole process. I think at this point, if you guys have some questions, I'd be happy to answer them. I know I kind of rushed through that quickly. Tried to give a high-level overview of what is going on here. So let me just kind of run up here and see what questions we have. So once again, the recording is going to be on cloudquant.com. I'm sure also FXCM. I think these guys get it out within 4 or 5 hours. R, Python. So I do everything in Python. There are guys here that use R, but for machine learning, the packages, there's some really great packages in Python, and our whole editor is in Python. So that's what I use. So you train on different models for different market conditions. So I would say you train you try and train your model. So the question is, do you train your model train different models for different market conditions? I think more than that, you try and train your model on market conditions that are similar to what you're seeing currently or what you're going live on. Stuff changes pretty dynamically in the markets, obviously. And a lot of times we're live trading and the machines are trying to predict things that they've never seen before. But I would say, in general, you're more just trying to match up market conditions that you're training on with what you're testing on. And then, there are going to be different algorithms that are going to do better with different data. So depending on the structure of your data, you may use a different algorithm for a different problem. A neural net might be way more powerful if you have enough data to use and you have the correct type of data, if that makes sense. A decision tree can only split on vertical and horizontal axes, whereas a neural net can split data, is not limited by that. So depending on what your data looks like, you would use different algorithms in some sense. And then I will definitely include the slides on the cloudquant.com post. I'll also include the trades.csv file, so you guys can go in there and actually run this Jupyter notebook. Probabilistic modeling, yeah. So we've definitely so probabilistic modeling is basically, instead of spitting out a single scalar value, it's going to spit out a distribution. It is a new kind of really exciting area that is getting developed. I have not personally done a whole lot with it. Scikit-learn has a really nice ability where you do this predict function right here. There's actually a predict underscore proba that will spit out instead of a 0 or 1, it'll spit out a probability of that trade being related as or classified as a 0 or 1. So I definitely use that. That is not really probabilistic modeling. You know, I think it is definitely, for the markets, using probabilistic modeling is probably really smart. I know TensorFlow has a package called Edward, I believe, that works. You know, it's integrated pretty well. But you know, a lot of the problems that we have is we train on data, and then when we're trading live with it, the data comes in a few milliseconds late, or you know, there's always, the data is slightly incorrect or comes in from our vendors or the markets just a little bit differently. So to have a distribution that is outputted, you know, something that's saying you've got this distribution and a 75% chance or 75% confidence that this trade is going to be correct, I would say that's probably way more robust and useful than having just a number spit out like 0 or 1. So as far as probabilistic programming, definitely would recommend, if you're interested in it, spending the time to learn more about it. I am certainly, that's definitely very high up on my priority list right now. Any difference between models for forex and stocks? You know, I mean, there's different, like obviously forex is gonna behave slightly differently than US equities, which are gonna behave slightly differently than futures. You know, even like mid cap and small cap and large cap stuff behave a little bit differently. So as far as the machine learning approach goes, I don't think there's any difference really. You're still gonna go through the same process and frame your problem in the same way. But I would say that, you know, you're probably gonna have a slightly different, you're gonna have different things work better for different market conditions or different markets. So a model that you train and build for US equities may not work quite as well for a model that you train and build for forex or futures. But if you were to go through the same process and build a model for futures or forex, you would probably get really great results out of it. You know, the model is just going to train slightly differently. You might be more biased towards a single model, depending on your data for the different asset classes. Yeah, so financial performance of our most active machine learning algos. So we have, you know, we've got algos that will take the opening print and then sell on the closing print. So just intraday, but just really simple, you know, buy on the open, sell on the close, and we'll trade, you know, a basket of stocks, or, you know, kind of a more traditional quant model that, you know, we'll get Sharpe ratios of 5+ on those, but the yearly return may only be 5%. And then we'll have other models, which are kind of the ones that I focus on more, that are, you know, more intraday actual alpha setups that may only have Sharpe ratios of 2 or 3, but, you know, could get 30 or 40% returns in a year. Just might be a little bit bumpier. But we have, in general, had pretty great success with machine learning. There's definitely definitely some hiccups along the way and a lot to learn. But yeah, depending on how you frame your problem there, you can build your machine learning model and train it to do whatever you want it to, if you do a good job. For a lot of the guys, they're looking to trade a lot more and get less out of it, so they're getting those 5 sharp ratios, but they're only maybe returning 5 or 10% a year. I am more looking to get maybe to trade a little bit less, but to try and hit the home runs when I do. All right. All right. For those of you who are looking to just learn how to code, like I said, and as you can see here, Udemy, Coursera, Udacity, I basically learned everything from just Googling free Python classes and then getting a Jupyter notebook, going in and playing around with it, and then Googling bugs that I found, and then courses on Udemy. It's like $10 or $15 for a pretty robust course. A lot of the machine learning stuff is on these sites as well. You can really get a lot out of the internet nowadays for pretty cheap. This book right here is a great machine learning, just kind of end-to-end overview. Starts with kind of more basic machine learning, goes through the ensemble methods, the random forest, and then we'll go into TensorFlow and the deep neural nets, which are pretty cool when you get to that point. Do you have to use a different model every day? No. So what we do is we will train a model. So I train normally on the previous 2 to 3 years of market data, and then I will retrain my model every month. So every month I'm going to create a new model that looks back for the previous 3 years, test that for the next month, and then at the end of that month I'll create a new model, looks back for the previous 3 years, and test that. So we're not creating it every day. You could in some sense if you wanted to, and you probably get slightly better results, but the overhead and the time spent doing that isn't totally worth it to us. Yeah, so neural nets versus scikit-learn. I mean, scikit-learn is really easy. It's just plug and play. If you want to get into this and you want to get decent results right off the bat, I would stick with scikit-learn for now. It's much easier to overfit with TensorFlow and with neural nets. The code is not nearly as intuitive. There are way more hyperparameters to optimize in a neural network, so you're going to have to, you're either going to have a really powerful computer, or you're going to need to spin something up on AWS. And once neural nets need more data in general to train on than a decision tree does. So depending on what your problem is, there are going to be, a neural net may work really well for something that takes 600 stocks a day and has pretty consistent market conditions that you can train off of a lot of previous year's data. So you can get a bunch of data and you can really take advantage of, a deeper neural net, whereas random forest decision trees are going to be much better straight out of the box, much easier. Use Renko or Point and figure it all. So I have not heard of Renko or Point. I mean, our data series, we are using, using a bunch of, I collect a bunch of minute bar data, daily bar data, and then we also have level 1 data. So we have every tick. We've got what the bid and the ask is on every NBBO update. So kind of keeping an eye on what the book is doing, and if the offers are disappearing or the spread is widening. Definitely looking at that, looking at volume, bid versus ask volume, things like that are kind of what I really focus on. What Sharpe ratio is? Sharpe ratio is just the risk-adjusted return. So it is just basically your percent return over the it's the standard deviation of your model, but it's basically for how much you return. It penalizes you for having a model that goes up and down wildly, but rewards you for having a model that gains a lot in some sense. So it's return over standard deviation of your model, kind of just a generalized metric in the finance world. Yeah, so on CloudQuant, I basically I pull all my data out of CloudQuant in the first step here, and then I'll do all my analysis in a Jupyter notebook here or just in a Python script. I'll train all my models outside of here and then upload the data to CloudQuant. When people get to that point, feel free to reach out to me, so I can kind of walk you through how to do that. Happy to help. Scikit-learn is supported in CloudQuant, so you can actually just pull in your CLF object and make predictions in CloudQuant here and get those during your backtest, which is pretty nice. You could also do all your predictions outside of CloudQuant, save them to a file, and then just save that file to CloudQuant's user data, and then read that file in for your predictions. All right. So learning is done on raw historical rather than trade history. So I mean, learning can be done on anything. At the end of the day, like when you're training your model, it's just being trained on any sort of data you give it. So, I'm using trade history or capturing the data on the trade just because that is the exact point in time that my machine learning model is going to be making the decision, is when I send or consider sending this buy order or sell order. So, I'm capturing my data right here because that's when my machine learning model will be making its prediction. But the data I'm capturing is raw historical data at that point, if that makes sense. And then, so right now there is not a desktop version of CloudQuant. It is all online here. I mean, you can write, sometimes I write code in like just a text editor or something like that, and then I'll upload it to CloudQuant. But in general, I'm mainly just doing everything right here. We have our documentation page over here that kind of gives you a rundown of everything. We've got a lot of really nice TA-lib, momentum, volume indicators, all sorts of things that you can kind of use while you're building your model. Like I said, we have a bunch of alternative data sets that we're implementing, which are pretty cool to try and see what sort of alpha you can get out of sentiment data or stock twits or things of that nature that 99% of the market does not have access to. There's definitely some gold to be found there if you can dig through it. Is there any benefit to offer testing on multiple studies? Yeah, so the walk forward. So for what I did in here, it was such a simplified version. I just tested on 1 year, but when I actually go back and do, like when I created this back test here, so this one runs from the beginning of 2015. I believe there's a second back test that I ran from the beginning of 2013 too. Normally I will test back to the beginning of 2013 or 2014 to see how the machine learning algorithm is going to do over that time period. No. All right. Yeah, where to start if you're just trying to get into this in general as far as the finance side of things goes. I think there's a lot of free online webinars out there and free online classes on the finance side of things. I mean, there's definitely, you can buy books on that. once again, I would honestly just Google stuff instead of wasting your money on, you know, a bunch of really fancy textbooks or online classes. Start by Googling stuff and trying to find free things. If you have a question, just type it in and see. Yeah, I mean, see what you get. All right, can you talk about your best model? Yeah, it's my best model right now. Uses light GBM, which is it's a gradient boosted decision tree or group of decision trees, which basically means that it's every time it builds a decision tree, it is trying to minimize the loss from the previous decision tree from a very high level. So it uses that. I think I have 50 features in my model. It's a reversal model, and it trades about 3 to 4 times a day. Yeah, it uses machine learning for the entry, so we kind of get a signal on whether or not to enter a trade. And then I also have a signal for the exit that is basically telling me, like, okay, this trade is rolling over, you know, get out, more or less. So I've got a couple different machine learning models built into it. But I am using light GBM for it. That's kind of my go-to nowadays. Similar to XGBoost, for those of you who know that, just runs a little bit quicker, which is really nice. Any algorithms you would suggest? So once again, I would suggest starting with random forest. Maybe even just starting with a simple decision tree first, and then starting with random forest, and then you know, from there you can really get into more complex things. I think the next logical step would be to go to a gradient boosted tree or add a boost, which scikit-learn has. You know, beyond that, you can look at maybe support vector machines. Once again, neural nets are kind of definitely hyped up a lot right now, but are very difficult to train and tune. Yeah, so neural nets, we have used them. We're doing more research on them for sure. For my trading applications, they aren't quite as applicable just because I don't have as much data to train on. You know, like my best model right now trains on, I think, an average of 80 to 120,000 trades on the walk forward basis, whereas a neural net would probably need more than that. I am researching some new algorithms that would potentially trade 300 or 400 times a day, and for that I am researching neural nets. And also researching holistic programming for the earlier question, just because there's so much more data. Is there any specific instrument that you've enjoyed more success with machine learning? So this, you know, I think what platforms CloudQuant works, you know, it's just, I would recommend using Google Chrome, but it's just online. Basically, after you create your algorithm in here, you know, if it backtests well, you can go to this Fund My Strategy page and you can ask us to basically fund it. And, you know, we'll throw, I think we've allocated $75 million so far this year, or yeah, so far this year to quantitative researchers. So, you know, we've allocated millions of dollars to kind of fund people who have come onto the site and created good algorithms. And then from there, we take this and we convert it into our live system that is, you know, connected directly to the markets, has access to all of the execution advantages, some of the more, you know, the algorithmic, the order algos to get around the high frequency guys. You know, there's all sorts of things involved in the market microstructure that we offer in a live trading environment that isn't included in CloudQuant. Is there a visual backtester, MetaTrader 4? So yeah, so this is, you know, I mean, our backtester right now is online here. It gives you, you know, it gives you kind of this scorecard. You can request all these reports as well on here that will give you an idea of how you're doing. yeah. And then right now we do not support options on CloudQuant. In live trading, we do have a lot of guys trading options, you know, so we are looking to, I mean, if you came on as a discretionary trader, we would definitely support options. Supporting options from a quantitative perspective takes a lot of work just because there's so many different strike prices and expirations. You know, it's definitely a bit of a task. So we don't do it from a quantitative perspective right now. And then I do all my testing on tick data. So tick data, you know, looking at the NBBO updates, the depth of book is definitely important. Yeah, data scientist. Okay, is there any particular? As far as a time frame for doing machine learning, I wouldn't say there's a better time frame to do it. I would say for different time frames and different market conditions, you're going to have slightly different models, and you may use slightly different machine learning algorithms. But you know, machine learning is really powerful if you know how to apply it. You know, when I first started, I basically had no knowledge of algorithmic trading for the most part, and was able to come in utilizing machine learning and get stuff up and running much quicker than I think I would have been if I hadn't utilized machine learning. And at that point, I was just using random forest, just using scikit-learn, keeping things very simple. You know, we have guys making a lot of money just using random forest. You know, more complexity is not always better. And then, can we access all the works of the data science from the platform? So on the platform here, we have this community section, and this CloudQuant forums has, you know, a bunch of things, you know, where our internal quants are talking about. You know, we have our support team is constantly out there trying to help people. So if you're on here and you're utilizing CloudQuant, make sure to, you know, you can once again shoot me a message if you'd like. It is ttrinkino@kirshnertrading.com. Here's our websites. But there's something up in the forums. We'll get back to you, and you know, hopefully you can make an algorithm and maybe make some money. You know, get it funded. All right, and then participating as an investor. We are looking to, you know, that's a question I would email me directly about if you're looking to participate as an investor. I think that is all the questions I see so far. If anyone has any other last-second questions, happy to answer them. Once again, if you'd like to, you know, shoot me an email. Make sure to go to CloudQuant's website and FXCM to see the presentation, the recording later today, and for all the Jupyter Notebook and CSV files. How I interact with FXCM. I think we're looking to do a few more of these webinars. You know, this was kind of I think I ran through a lot of things very quickly today, so hopefully I didn't lose too many people. But I think we're looking to do kind of a series of these machine learning webinars, and you know, maybe get into some more advanced stuff, get into the gradient boosting. You know, I can show you guys some of my actual algorithms down the road. Obviously not showing all the code, but you know, happy to show some of the more kind of advanced strategies, and then you know, maybe even getting into some neural network stuff as well, because I know a lot of people are really interested in that. Yeah. Okay. Okay. What platform does it work on? So if you're talking about CloudQuant, it's all online. Our proprietary trading platform that we actually go live with is platform independent, actually. So you know, it's Windows or Linux. but we basically, what we do is if you were on here and you created a strategy and it was working, we would take the strategy, bring it to our proprietary platform, and basically run it for you. So we would throw in the order execution. We would route the orders to different market centers. We do all that for you. All right, and then trading integration with FXCM. I think we're still kind of figuring that out, so tune back on that one. All right, any other last second stuff? All right, guys. Well, I appreciate the time. Hopefully that was helpful and at least spark some interest. I would say, for all of you guys looking to get into it, for those of you who don't know how to code Python, don't be intimidated. It's pretty easy. Go out there and Google stuff, learnpython.org, DataCamp, Udemy. And then for those of you who do know how to code Python, haven't done machine learning, hopefully some of this kind of made sense. It is incredibly powerful. Once again, just go Google stuff, learn about it, shoot me questions, tune back into FXCM for some more webinars down the road. Go play around with CloudQuant, see if you can get a script to run correctly, and then kind of iterate from there and see if you can start incorporating machine learning. All right, guys. I will all the best.